Hello everyone and welcome to our fourth video of Unit 1. Today we are covering transversals and their converses. We're going to go ahead and get started with drawing two parallel lines cut by a transversal. So in the space below, draw two lines parallel to each other, then draw a third line that is not parallel to the other lines and intersects them both. So first thing I want to do is draw two parallel lines. The easiest way to do that is to pull up a ruler, and we're going to put that in our blank space there. Now I'm going to take a pencil and I'm going to trace along both edges of the ruler like so. And these are lines, so we should have arrows pointing in both directions off the end of those lines. Now it says to draw a third line that crosses over both lines and is not parallel to either of them. So I'm going to go ahead and just put my ruler at some angle between them. There's my third line. I need to give it arrows. I'm going to go ahead and put my ruler away now. Alright, so I have two parallel lines cut by a transversal. So this line that intersects both lines and it crosses over both lines, this line is what we call a transversal. So we have several properties and angle names that we use when we're looking at the angles that are on a transversal or on potentially multiple transversals. We're going to stick with just one for now. And we'll start with corresponding angles. So we have the corresponding angles. We want to circle them. First off, you need to know what corresponding angles are. So corresponding angles are on the same side of the transversal and they are on the same side of the parallel lines. Same side of each parallel line. And just a reminder, these are talking about corresponding angles. Alright, so if they're on the same side of the transversal, well, our transversal is this line T. So they're on the same side of T. Let's pick the left. And they're on the same side of each of the parallel lines, which are lines M and N. So if they're on the top side of both parallel lines, then the corresponding angles are angles 1 and angle 5. They're on the same side of the transversal and the same side of each parallel line. Alright, so we also have alternate interior angles. Alternate interior angles, we'll label here a second. Alternate interior angles. This is not an official abbreviation by any means. But in the future, you will often see me write AIA, which stands for alternate interior angles. Alternate interior angles are on they're non-adjacent angles on opposite sides of the transversal. So non-adjacent angles on opposite sides of transversal and between the parallel lines. So if we're looking at non-adjacent angles on opposite sides of the transversal, so I'm going to have something on the right of the transversal and something on the left of the transversal. Then it says that they're not adjacent. So I can't pick 3 and 4 because those are adjacent, but 3 and 6 could work. Then it says they're between the parallel lines. So that means that they have to be either angle 3, 4, 5, and 6, one of those angles, because those are the only ones between the lines. So if I have to be on opposite sides, they can't be touching and they're between the lines. 3 and 6 are a good example because they're non-adjacent, they're on opposite sides of the transversal, and they're between the parallel lines. 4 and 5 would be your other example there. There are no other angles in this image that are alternate interior angles. All right. Next we have alternate exterior angles. Alternate exterior angles are on opposite sides of the transversal. Opposite sides of the transversal. And they are on the outside of the parallel lines. Outside of parallel lines. And again, those are alternate exterior angles. Like alternate interior angles, you'll also see me abbreviate that as AEA in the future. Not an official abbreviation, that's just my shorthand for notes. If you want to do that in your notes, that's fine. On an assessment, you would need to be able to write the whole thing out. All right, so alternate exterior angles, opposite sides of the transversal, outside of the parallel lines. Okay, so if we're outside of the parallel lines, I have angles 1, 2, 7, and 8 that apply to that. Then it says they're on opposite sides of the transversal. So if I pick 1, then I have to pick either 2 or 8. The other thing that I just realized I forgot to write in here is these are also non-adjacent. So we have non-adjacent angles on opposite sides of the transversal is what that should say. So let's go ahead and edit this here. We're going to just add to our top line here. I'm going to draw a little caret. Non-adjacent angles on opposite sides of the transversal. Alright, so if they're non-adjacent, I can't pick 1 and 2, but 1 and 8 would work. So 1 and 8 are on opposite sides of the transversal, and they're both outside of the parallel lines, and they're not adjacent. Alright, last we have the same side and interior angles. And same side interior angles, let's just go ahead and label that real quick. Same side interior angles. I'm getting ahead of myself by explaining without labeling what I'm explaining. Same side interior angles are on the same side of the transversal, as is in the name. Same side of transversal. And they are between the parallel lines. So if we have same side of the transversal and between the parallel lines, we're either looking at 3 and 5 or 4 and 6. Both of them are examples of same side interior angles. Let's go ahead and use 3 and 5 today. So they're between the parallel lines on the same side of the transversal. All right, let's go ahead and look at our first postulate for our angles here. All right, so we have this corresponding angles postulate. The corresponding angles postulate says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So what that's saying is that angles 5 and 2 and 7 and 4, or rather 5 and 7 and 2 and 4, and we know that these are vertical angles, so these are congruent. So 5 is congruent to 7, 2 is congruent to 4. 5 is also congruent to 2, 4 is congruent to 7. So 5, 2, 7, and 4 are all congruent. But this postulate specifically is saying that 5 and 7 are congruent, and 2 and 4 are congruent. This postulate also lets us know that 1 and 3 are congruent, and 6 and 8 are congruent, because those are also corresponding angles. And let's go ahead and just mark those out here. So I have 1 and 3 and 6 and 8. Those are congruent. All right. So let's go ahead and look at some theorems that the corresponding angle is used to prove. So I have the alternate interior angles theorem, which says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So let's go ahead and put our numbers on our chart here. So I have angles 1, 2, 3, 4, 5, 6, 7, and 8. I'm actually just going to go ahead and do this for all of the pictures real quick, so that we have these numbers pre-drawn as we go through here. Maybe should have just put them in there in the first place. So if I have pairs of alternate interior angles, let's look at, for example, alternate interior angles 5 and 4. So I can conclude by the alternate interior angles theorem that angle 4 is congruent to angle 5. All right, so that's the alternate interior angles theorem. Next we have the alternate exterior angles theorem, which says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So if I have these two parallel lines cut by a transversal, then I know, for example, let's pick 1 and 8. Angle 1 is congruent to angle 8 because they are alternate exterior angles. Next, you might see where this is headed, but then we get a little bit of a change here. Same side interior angles theorem says that if two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. Supplementary means that they add up to 180 degrees. So they're saying, well, first we have to identify our same side interior angles. Let's go with 4 and 6. So I have 4 and 6. If they are supplementary, then angle 4 plus angle 6 must equal 180 degrees. And that's my conclusion. All right, so let's go ahead and take a look at an example here. We have this apply what you know section. It says to use the image to the right over here to answer the following questions. Number 1, if we know that angle 2 is congruent to angle 4, why is angle 2 also congruent to angle 7? We have parallel lines cut by a transversal. These are corresponding angles. Angle 2 to angle 7 is alternate interior angles. So the reason is because of the alternate interior angles theorem. THM is an abbreviation for theorem. Number 2, if we know that angle 2 is congruent to angle 4, why is angle 5 also congruent to angle 4? And as I'm looking at this, I'm noticing that the congruent symbol that's in here is not the correct symbol, so just ignore that. That should be the congruent sign. That's a note to fix that for future years. I'm wondering if that could be a formatting issue between Google Docs and the PDF, but congruent is what we mean there. So 2 to 4, why is 5 congruent to 4? 5 and 4 are alternate exterior angles, and we know that these are parallel lines cut by a transversal because these are corresponding angles and they're congruent. So angle 5 to angle 4, we would say alternate exterior angles theorem. All right, number 3. If we know that angle 2 is congruent to angle 4, why does angle 2 plus angle 3 equal 180 degrees? They're saying that these two angles are supplementary. We know that these are two parallel lines cut by a transversal. So the answer is same side interior angles theorem. All right. So now that we have talked about transversals, we're going to go ahead and look at the converse of these transversals. So let's go ahead and flip to the next page here. This is our last page in this packet. And it says right up at the top, if two lines are parallel with a transversal, the corresponding angles are congruent. That's what we had before. Now we're looking at the backwards version of that sentence, and let's zoom in on that up here. If the corresponding angles are congruent, then the two lines must be parallel. So it works both ways. If the lines are parallel, the angles are congruent. If the angles are congruent, then the lines must be parallel. So what we're going to go ahead and start with is the converse of the alternate interior angles theorem. And I already pre-drew the parallel lines in there, but let's go ahead and label those once again. So I'm going to switch my pen back over. Let's see if I can make this a little smaller so it will fit a little better, I hope. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, now that we've got those in there, let's go ahead and take a look at these theorems. All right, the converse alternate interior angles theorem says if two coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the lines are parallel. Okay, so if we have angle 3 is congruent to angle 4, then I can conclude that the lines are parallel. Okay, so let's draw this in here. Angle 3, I'm saying, is congruent to angle 6. I think I said 4 before, but I meant 6. And that kind of looks like an S, and I don't want it to look like that. So let's just try to make this a little smaller in there. So angle 3 is congruent to angle 6 in my picture. I have the angle markings. Oh, you can't really see that on the screen. All right, let's go ahead and rethink this here a second. We're going to keep the measurement or the angle names there. I'm going to draw a smaller, larger arc. Okay, that did show up pretty good. So let's switch back to the blue. Okay, so angle 3 is congruent to angle 6 in the picture. And I'm going to label these lines, and we should be giving them names. And we also should be drawing arrows and markings on these as well. So we know that we have, let's label these. So I have, let's call the transversal T in all 3 pictures. And we're going to call the top M and the bottom N in all of these pictures. And we should put arrows on them, but we're not going to at the moment. We should also mark that these are parallel. So if you don't remember, to show that 2 lines are parallel, we want to go ahead and draw arrows on the line. So because I have 2 arrows here and 2 arrows there, I know that these are parallel. So let's go ahead and add that to each of these. You could use 2, you could use 3, and you could use 1. So let's go ahead and there we go. And we're going to just assume that these are lines continuing forever for this problem. All right, so in conclusion, because angle 3 is congruent to angle 6, then I can say that line M is parallel to line N. So I have line M is parallel to line N. So these 2 lines kind of looks like 2 lowercase L's or 2 capital I's, depending on how you would type it. But this means parallel. Line M is parallel to line N. All right, now let's look at the converse of the alternate exterior angles theorem. So if you have 2 coplanar lines cut by a transversal so that a pair of alternate exterior angles are congruent, then the lines are parallel. So I'm proving that these markings are true because I know that the alternate exterior angles are congruent. So if I have on my picture that angle 2 and angle 7 are congruent, then I can say in conclusion that line M is parallel to line N. All right, so we're starting to see a pattern again, but that's when things change. The converse same side interior angles theorem says if 2 coplanar lines are cut by a transversal so that a pair of same side interior angles are supplementary, then the lines are parallel. So if I have angle 4 and angle 6, and I say that angle 6 plus angle 4 is equal to 180 degrees, and I know that this is true, then what I can conclude is that the lines are parallel. Line M is parallel to line N. So our conclusion is the same, but we got there in a different way. So before we were saying the angles were congruent, now we're saying that because the same side interior angles are supplementary, then the parallel lines are parallel. All right, so let's go ahead and look at an example here. We're going to use this image to the right here to answer some questions. It says, use the image to the right to answer the following questions. Number 1, if we know that the measure of angle 2 is equal to 110 degrees, what must the measure of angle 1 be so that the lines L and M are parallel? Okay, if I'm trying to prove that the lines are parallel and these are corresponding angles, then that means that this angle needs to be congruent to angle 2 in order for them to be parallel. So if the measure of angle 2 is 110 degrees, then the measure of angle 1 also must be 110 degrees. All right, number 2. If we know that the measure of angle 2 is equal to 100 degrees, what must the measure of angle 4 be so that the lines L and M are parallel? Okay, well these are on the same side of a transversal, and they're between the parallel lines. So I have same side interior angles here. So in order for these to make these 2 lines congruent, 2 and 4 have to be supplementary. So if 2 is 100 degrees, then angle 4 must be equal to 80 degrees because 80 plus 100 is 180 degrees. All right, number 3. If we know that the measure of angle 3 is equal to 95 degrees, what must the measure of angle 2 be so that the lines L and M are parallel? All right, well, 2 and 3 are on opposite sides of the transversal, and they are on the outside of the parallel lines. So I'm working with alternate exterior angles here. If the lines are to be parallel, then these alternate exterior angles must be congruent. So that would mean that the measure of angle 2 has to be 95 degrees as well. All right, this is where we're going to go ahead and stop our lesson for today, and this also does conclude our unit. We will go ahead and have some review time, and then we will follow this unit up with a test, which you can find more information about on Canvas. Our next unit will be about constructions, and that will look a little bit different, so make sure you are reading the instructions on the module posts because it is not going to operate exactly the same way this unit did. And we'll talk a little bit more about that in the future.